that you can't control it, so the people who wants to run it. So and why that my parents are also there. So they said to park it in the corner, and I was usually not where I went. And finally one lady said, opposite there is a road, so park it over. Last time we parked it. Somewhere in the ladies hostel. I was right. Me also last time I took a
शुरू करते हैं सर चलो okay similar to this we all know sequel injection I don't think I need to explain what is sequel injection just skipping this till then how many of you had sleepless nights for this one?
yeah. Yeah, I mean,
One weekend, right?
yeah, everything one has to be done like in a week.
Because we were expected to fix it, and most of applications that vendor dependent, we need to rely on them.
And the problem here is the main vendor, like the Apache, they published probably two or three, I think three patches on this. The first patch they published, the next day again it was hacked, it was attacked, and then they published second one, and third time they said, okay, now even the second patch is not, this is the third patch. So the entire to and fro communication happened three times. Okay. So at least all of us know what is really heard about it. So this is also something that was a result of an insecure system. And it's if you want to know what actually has happened, it is nothing but like whenever you get asked for a GET request to any server, you ask for the user agent. Usually it is your browser. Now if somebody just cracked this one like this, what happens? Log4j is the logging system. It whatever is the log, it just logs. So it logs like get this one user agent Mozilla, it logs. User agent this one, user agent is this one, it just logs. Everything is logged. And this particular meaning JNDI has a specific meaning for the JNDI server inside the application. And it actually connects to the LDAP and it gives you all the LDAP information and it gives you some information by which you can actually do RC, remote code execution. So it's nothing, just a simple HTTP request you have to create. That's all. Everything is gone. Your entire LDAP system is compromised. LDAP means the same system that you use for single sign-in in your office. One single password, once you enter in your system, that means you can access any of the applications. The same username and password work. That's the LDAP system. Right? So that is gone. So that's the thing, and you can think what like the magnitude of the problem. That means log4j was used by how many? If I'm not wrong, like 80-85% of all the web applications, all the companies, everybody is using Apache, and log4j is a major part of that, and it was vulnerable. And it took so many years to find that there is a problem. But the thing is, if there is a vulnerability.
So considering HTTP is been for more than a decade and all those things, why it was not captured before and it got captured now?
People did not find it. It is there. It is a flaw. Now somebody need to find that flaw, right?
SMB was also there. Or one of them.
SMB2 was also there for long time.
But was there a patch that was provided and that has this vulnerability or something?
For SMB or this one?
For this one.
Yes. The log4j, the first patch, probably 1.2 version was vulnerable initially. Then they released 1.3. Then they released 1.4. Now I think 1.6 is the most recent one, which doesn't have vulnerability. In fact, it also happens. Like there was, I forgot the example, but this also happened. There was a vulnerability. People come up with a new patch. That patch is creating new vulnerability. And once it is out, then there is so much of attention on that. Now, whatever you do, if you create a new patch, whatever people are interested on that. So many hackers are there. They are interested. Hackers, kiddies, the smart guys are there, smart and dumb or both, and they just keep on doing a lot of things and happens. So now these things happen. So what I wanted to say with the buffer overflow, with secure injection, with log4j, shit happens. We really cannot control it. Whatever we make, it will have bugs. Some of the bugs are considered as vulnerability. It will happen. We cannot control. That's how the industry works. Because codes are written by human beings.
Till the time it is not exploited, it is.
Yes, even I can introduce vulnerability without knowing it, or even without the entire world knowing it. The world does not know that this is a vulnerability. Okay. So this happens. So how we can tackle these things? Now let us understand all these attacks on the application or software or in information system. All these attacks happen because there is some flaw. The flaw might be logical flaw, that law might be design flaw, that law might be a policy related flaw, that law might be implementation flaw or the engineering flaws. But there are flaws, that's why it is happening. There is no stupid code, that means there is no vulnerability. Everything is secure. The other way to secure everything is don't write a stupid code. But we know our industry is full of stupid. And even it is not like always the coder's fault, but it happens because it's such a big thing. We are dealing with so many repetitive code lines. We are reusing codes. We are reusing libraries, and one more thing that usually happens when you build, because I find it with my developers a lot of time, they copy codes from some GitHub location, share code, or whatever places are there. Kuda 7 and though many of those has deliberate vulnerability. They want copy our code. They want copy our code. Then we'll see. And how you can stop that? And everybody everywhere, I know you guys do not write code, but if there is a developer sitting here, he would agree like I cannot do my job without copying codes from GitHub. I cannot do. I do not know everything, right? If somebody is asking, like tomorrow, my manager will ask, provide this feature. I do not know how this feature works, so I have to borrow someone else's code, and that someone else might be mysterious guy. So there are flaws, and we have to tackle the flaws. So the best way to achieve security, like one of the ways to achieve security, is the testing part, software testing. Intel, you have seen Intel, say Intel Pentium, Intel's i7 or i9 is there. You have seen the same i7 processor has different price values. You can get it in 25,000, you can get it 50,000, you can get it in 1 lakh. The same i7 processor, different numbers. What are the differences?
Overclocking.
Sorry?
Overclocking.
Yes, overclocking is one of the even though you can find same configuration, but there are different price range. Same configuration, even though if you overclock,
One has discrete.
and secondly overclock. When you say overclock, actually the lower one, which does not say that overclock is this much, you can actually overclock in a higher speed. They say overclock because I have tested till this. I have not tested beyond that. It can work. You can overclock more, but I have not tested. I don't guarantee it will work. So the main difference for most of the cases, if it is a processor or a hardware thing, even for the software, the major difference is testing. The same business. This is a business laptop XPS, or Dell Latitude is a business laptop. So the business laptop costs almost 1 lakh, 2 lakh, something. The same configuration, even the better configuration, you can get it 30, 35, 40, 50,000, right? The difference is the business laptop are tested more.
Rugged. It's a rugged laptop.
Yes, rugged. That is stress tests are done. If it is a software, then the vulnerability test. So how many times you are testing? That is a rigorous. Now creating the test case is fine. Like I have tested 1,000 test cases, but 1,000 test cases does the same thing. Doesn't make any sense, right? So different, finding out different corner cases, different type of errors, different types of bugs. That's the art of writing a test cases, right? So that's why writing those test cases, testing these things. In fact, in Dell, I know people whose job is literally hammer on the laptop. They just literally hammer on this. Okay, I hammer with this force, it worked. Hammer with this force, it worked. Hammer with this was this break. Okay. This and they put it in a freezer, like in a freezing temperature. They put it in the microwave. They put it in a very high temperature on the furnace, something like that. And that is kind of testing they do. You said ruggedness. Yes, that's what it is. Right. Sorry.
Not more than 4 feet. So his laptop also not more than 4 feet.
Yes, that's the boundary condition. Now they said, okay, I need a laptop for the business people, there were people who are having job in some software companies, and they want to throw it from the second floor balcony. It is not a very rational expectation or rational boundary, right? Yeah, 4 feet is fine. I can it might fall from my hand. That's why those boundaries. Now again, that is again a threat model. Again, they perceived a threat. Okay, 4 feet is my boundary I can put. Now, if somebody does, now there are something called these your military grade systems. Military grade systems actually they can survive a bomb blast also if they made it like that. Yes, there are systems which are military grade systems.
Now the dynamic cookies, that recommended for making dynamic cookies.
Yes. So all these things are there. Now we understand all the software has bugs, but that is something to do with our security. That is something we should be scared of. We should care that. And most of the cases, normal users do not see those mistakes or those vulnerability. Who would see these log4j vulnerability? That is, yes, that is a error, that is a bug. But the people who did the testing, they never thought of this. First of all, they never thought of this corner case, right? And even if they do, I don't know, they might have come up with this scenario. There might be some very creative tester who did it. Then also what happens? Normal thought process is, let's only fix what's likely to affect normal users. That is a very big problem, and that is how our industry works. And all these things I am saying, there are two things, mostly 2-3 facts I am just repeating again and again. One, there is a business wants something else. Security is not the business priority. So business prioritize something else, but we security engineers, we have to prioritize something else. We have to find a trade-off between these two. And second, everything has an error. Everything starts with some error, some bugs, and we have to take care of that. And thirdly, how we can find out those bugs? We need to have a security mindset. We have to think in a different way, the way hackers think. Then only a good cop is always a good criminal. That's how we have to work. So I have already covered this one. Every system has bugs, and a subset of these bugs are called vulnerability. There is no silver bullet. There is no one single process that will secure everything. And there are tools, there are techniques, there are technologies. A competent security engineer would know everything, and they know where I should put which of these tools, which of these techniques, which of these technologies. And since you guys are not going to be a security engineer, probably you should know everything a little bit, so that at least you can understand the context everywhere. And one of the major tool or technique is cryptography. We will cover that as well in the next day. CV is over by like year after year, so now we see there are 20,000 CVs reported last year.
I think COVID played an important role.
Yes.
Gone way ahead.
But it is, see the trend, it is, yeah, 17 there was no COVID, right? The trend was like this only.
But the peak is in 2021.
Now we don't know what will happen in 2022. We have still 6 months left. But this is really not enough. This does not tell you the real picture because only 20% of the data has been reported in CVE. CVE does not record everything. That's the problem. So if you just see there are 20,000, which is 20% of the actual one, that means it is 20,000 into what? Into 5, I guess. 5 times 4. Right? And system with at least one CV is 43%. System with more than one CV is 30%. And system with more than 10 CV is 4%. And we all are using all these systems. These systems include our banks, include our social security like Aadhaar, all these things are government websites, portals. It includes our mail, whatever we use. Okay. So this is the number of vulnerabilities that is, and this data I got from scan. And I said there is always a trade-off between security, functionality, and ease of use, and everything relates. The entire world relates around one single tool, which is cost, the dollar value. Okay, and you know the business is always inclined to get it functional, like more functionality is good for business. More ease of use is good for business. System is good for a business, but it doesn't have any KPI, it doesn't have any metric. That's the problem. Right? Our developers write this kind of code. Yes, they do. I am using the best grade of the cipher, cryptographic ciphers, but where I am using it, there is a SQL injection. I have not done the sanitization properly, but I am using crypto-resilient ciphers. What's the point? Okay. So this is a major problem in our industry. Okay, we have already covered a lot about this thing. Now only testing. Is it now the question is? Yes, testing is one of them. Is it only testing? No. What else? Testing comes here in the middle of the software development lifecycle. All of you know software development lifecycle. At least in your BTech days you have studied, right? All here are at BTech, right? If I'm not wrong, but in different stream, but from engineering. Okay. In BTech, of course, people have studied that software engineering is a subject, and in industry, of course, you know that how this software development lifecycle works. So it is there in the middle of the software development lifecycle, but there are something design. When I am doing the design, I have to think about security. When I'm coding, that time I have to think about security. And once coding is done, then only I can do the testing. If there is no code, what I will test, right? So testing is one of that, but there is design, coding, and after that pre-deployment and production. Yes, we are running firewall, we are running SIEM, we are doing lot of cyber security stuff. If it is an application, we are checking logs, Splunk, and all these things we are using, right? So those are there. But there is one catch. The catch is if I find an error, or if I know there might be an error and I want to fix it, if it is we do it in the design phase before the coding starts. If it costs say $10, when it is in the production, when we find a log from the log I found there is something, or doing some pen tester or doing some bug bounty I found there is an error, that will cost $30. If it is $10, it is $300. So 30 times more. Yes, testing is a very good thing, which is kind of 10x, because everything we really cannot find in the design phase. Because our mindset is, if we want to build a house, who is going to pay the money to the architect? Let's hire a civil engineer or a contractor, and I want this one just built. That's what we usually think, right? Even the business people also think the way. So when in the design phase, if somebody really needs a security architect to be hired, and that security architect will work with harmony with the product architect or the application architect, it hardly works. if that architect, like application architect or the product architect, he knows about security, he is concerned about security, it is well and good. He probably will not will consider the security steps in his design. But if he does not, then the problem starts. If he does, it solves the problem, it is just a 1x cost. But later, the cost increases. Okay? And the cost, if even if it is not found in this production or post-release phase, if it is not found with the company, GDPR charges 4% of the annual turnover. Annual turnover, not profit, not anything else, annual turnover. Or 20 million, whichever is higher. 20 million, I really do not know how big it is. And Equifax paid 570 million. Actually, there are so many zeros, or it all looks the same. I really cannot count that. I really don't know how much stuff I can buy, even if it is rupee.
200 crores.
Two, I think 5,000 crores. If it is
No, for GDPR.
a GDPR, yes, it is some 5,000 crores, right? How many stuff you can buy with that? Because after some time, my mind does not work. Okay, this is how many zeros are there and what I can do.
Beyond threshold, which we expect.
Yeah, it is beyond my threat modeling threshold. I cannot say. Okay, so this is what. So, but it seems to be a very big number. Every CEO gets scared with this number. What you had? You had?
I'm saying 5 million ही बहुत है.
अच्छा.
He is counting slide, but he is imported 5
Okay, now let us go. We already told what a threat model is. We probably did it with the house example. I think we have 15 minutes. We can start it. Let's start with. So, yes, stride. So stride, I don't know whether everybody will connect with this stride model and on, but yeah, again I am just putting it in a lighter note. Yes, I have all these things. Like, just let me know if you can connect with this. Otherwise, we'll just make it much more lighter level, or the way the previous one, the introduction section. So, does it is fine, right?
Yes.
I didn't go into very technical part, or didn't it's
No,
not like
go into technical.
sure everybody.
Try to absorb. High level, everybody.
Sure. Yeah.
Nowadays, interview
In cryptography, I will see.
I know how you implement it.
Okay, but next week cryptography. We'll see. No.
I can as much as possible in the class, sir. In exam, it will be let it be highlighted.
Good point. Very good. And encryption is my favorite subject.
Wow. Okay.
What do you think is you don't know much about it? That's it.
We had discussed no homomorphic encryption. What we call.
Okay. Okay. Yeah, you called me. Got it.
Encryption is very interesting because he started with that.
But that I had to completely learn about it. Cryptography, encryption. Now if I start now,
problem
it takes me a
ढूंढता
minute
हुआ
to complete
आता
the
है.
research. But I'm going to do the project itself.
Okay. So let's start with this slide. Who do the threat modeling? First of all, who do the threat modeling? The hackers do. Yes, hackers do. Yes. Otherwise, how they can find a. So the bad guys will do, keep on doing if the good guys do. If we don't do for our software, then I can expect somebody else to do it. And it is a repeatable process, highly repeatable process, because we really cannot see a model or we cannot see the entire software or application as a whole. We have to start from a small, we have to start small and then we have to repeat the process again and again and again so that we can go deeper. So first it is just one level system, just input output system, and then we'll finding what happens inside. Then in that box again specify what happens inside. So it's a repetitive process. And who finds like this tech model reports? Who use this tech model? Who are the target audience for us? Think about the household. If the architect comes up with the tech model, who use passing? So the target audience of a threat model is the testers, the developers, the engineering team. They would know that this might go wrong what I am building right now. So these are the things I have to study. These are the things I have to test. And what exactly we are doing? We are trying to find out the different attack surfaces. Attack surfaces means are the from where an attacker can make a successful attack. What is the weak point in the attack surface? And even though like we can find the attack surfaces, we can find the threat, but that is not the end. We have to assess the risk also. The risk part is required to prioritize the threat. Which threat I am going to fix, which threat I am not. What might cause me a damage, what might not. And how we can mitigate these threats using different security controls. I think security controls, this term is known to you. You have already heard about it. You guys already know it. Right. In the secure system, we discuss about this how this is a secure system. How we can start the threat modeling on that. Yes, there might be a threat model starts with the door. If there is no lock, somebody can break this one. Somebody can enter from the chimney. And how we can stop these things? What are the security? So who can enter? Like of course my guest should enter, but a burglar should not enter, right? So for that, what I will do, I will put a lock. When I'm inside, I will keep the door closed.
And keep the gun with the mat.
That is actually a vulnerability. That's a vulnerability. Yes, that's a vulnerability. There is a threat, and for the threat, instead of mitigating it, I am putting the vulnerability.
Don't break it, bro. Just break it.
Yeah, I can save the door, but not the asset inside. So if in my mind the asset is the door, not anything else, then it's better idea. That's why I said your threat model is not my threat model. Okay. Of your Batman fan.
Everyone,
Okay.
especially Joker fans.
Okay. Now if Batman wants to do a threat model, now let's come to a real world scenario Batman. Okay. So if Batman wants to secure his assets on Gotham City is a very big one. Okay. I'm just thinking about only Bruce Wayne's asset. Gotham City is not his asset. Right? He wants to protect that. But what are the assets he has? He wants to protect.
Assets will be bad movie.
Batmobile. Anyway, he breaks Batmobile every single second, right? He breaks and damages
First,
the
we need to
Batmobile.
encrypt his system.
Yes. So the Batcave. The first one is the Batcave. Somebody gets entered to the Batcave, like if his identity will be revealed, his plans will be revealed, his systems and everything will be revealed. A very big asset, right? Because the only person probably he cares,
Who has access?
who knows everything, and he cares. Batman cares a lot about this person, right? I'll take his mobile SMSs, his mails. Okay, there might be more. We just let us consider these four. Like we have to limit our threat model somewhere. So we are considering this. That's it. If we want to go more, it is a repetitive process. Okay, this 4 has done. Now next, go to the next iteration. What are the other? So in Batcave, what are the now? For the way Batcave is an asset first we thought. Now in the Batcave, what are the different things I want to protect? The next iteration. Then maybe his laptop or his system. Then in his system we can go, okay, these are the files I want to protect. So this is the repetitive process. That's why I say threat model is a highly repetitive one. We start with the context level. Many people stops at the context level, but the good threat model or the best threat model is always the iterative one. Just go down, 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 down. Okay. So these are the assets Batman has. The attackers. Yes. This guy is madly looking for Batman, who his identity, or all of our love, and also the journalists. Right? Now these are the assets, these are the attackers. Now we'll see the attack vectors. Attack vectors means how they can make the damage. There are two attack vectors I am considering, which is a highly vulnerable one and a less vulnerable one. This is a less one. This, if the police goes to Batcave, Gordon, right? Yeah, Gordon goes to Batcave. What he will find? He will find something he will not understand first of all, and secondly, he cannot identify who the Batman is. Whether it is the Bruce Wayne or anybody else, he cannot identify it from the Batman. Just go to the Batcave. So this is a less vulnerable one. But this is a very vulnerable one. If he finds a message, he might understand who the next. Now come to, yes, this is the highly vulnerable one. He would go, he can damage everything. The most vulnerable, I guess, this one, because if he kidnaps Alfred and knows Alfred has something to do with the Batman, then Batman will be in a big trouble. At any cost, he would he would go to save Alfred. And the journalists, they are only bothered about these two things. They anyway cannot go. Sorry?
Girlfriend looking into the messages.
I think this is not the girlfriend. This is that
No, I was
the
just
journalist that. What's her name? I forgot. Me. Somebody. Journalist. Anyway. Now we need to think about what are the security controls I can think of. Yes, to stop the police, a security system is good enough. To stop Joker, a better security system is required, because Joker is much more intelligent than Gordon or any other police. This is a security control, hide Alfred somehow, or there might be others also. This is one of the security. So when the architect designs the threat model about the designs of security controls, this is one. There might be thousands of different controls. Now the architect should know which of the technique, which of the technology, or which of the control I should use here, so that my asset will be based. So this is
like even in the code there are thousand in one application there are thousand scenarios. I only want to use two, and I will disable everything else.
yes, features required that I enable rest of the things. Like disable most of the ports. That's a very common thing, right? In the network scenario, we usually disable all the ports that are not required. Only those ports which are required, I will open. So that is one way. So that is one control. Now, which control will work better for which asset and for which attackers? That is the challenge. That is why we need experience. That is why we need education. That's why we need knowledge. So this is one way. There might be other ways also. Hiding Alfred is one way. Simply encrypt your message, your phone, your laptop, your mails. It will solve the problem. As I said, your threat model is not my threat model. This happened in Sweden during some hurricane. So probably this is a threat model for this guy. He would have put a metallic sheet here so that a flying shark cannot enter. But that's not my threat model in Bangalore. We will not have flying shark. Even this guy you would never thought of, probably after this think you okay, this is something I did not consider. Or this happened in Thailand. So this is a threat model probably those guys will consider or
Recent one.
this is a recent one, yeah, and
Yeah, April
22, yeah, April 26. But you see, for very good cyber security to it has only these many lines. It's not like any.
I mean, it is evident, whichever is informative, it is always less. Yes.
Kangana Ranaut's post has more than that.
It is different threat model altogether.
Yeah, it's a different. So that's why I said your threat model, what you want to consider, I might.
No, the thing is, this is threat model, that is fashion model.
No,
So,
your name will appear in your tweet. Still, that is.
Okay. Now let us come with something. Now you guys will tell me if I want to secure a website. Say there are one bank website. What are the assets? What would be the assets for a bank website? It's like
all PI information,
sorry.
PI information, customer ID.
Do I have a document?
So it's here. You can use this board international data.
Okay, this is good.
No, no, but you need to protect the website.
Asset
Okay. Let's ask
For website, for website.
Website itself is there.
Website.
So let's first we
Web server is yes.
website. Some bank website, okay? Some bank website. Sorry for my handwriting. What might be the asset? Web server, somebody
Web
said.
server, server,
Okay. Then
API gateway,
gateway,
bank SSL certificate.
SSL certificate, okay. Then the application itself. Web application. The infrastructure, IT infrastructure, like if it is hosted in AWS or something in a cloud scenario, the things are different. But most of the banks do not rely on any
Perimeter.
yeah, perimeter infrastructure. What I mean.
Database. Logs.
Network. Internal network. You know, there is two different spelling. One is internet, and is internet. You know the difference?
Intranet is internet.
No, internet. Both are internet.
Yeah,
I capital, I small.
I had read somewhere, but
This is actually the www or the world or like the bigger internet that you think of. And this is different intranets connecting together. So the bank has maybe different branches in different cities where they connect.
I capital is www.
What is intranet? Internet.
Intranet is internet. Just giving you an example.
Intranet will comprise.
Say for Standard Chartered Bank, in Bangalore they have their own network. In Bangalore branch they have all the computers and servers and everything connected. That is intranet. Now they have the similar setup somewhere in Hong Kong as well. So similar thing in somewhere in Europe, and they connect all these internets together. That becomes internet, like intrastate and interstate. What is the difference? Intrastate within the state, interstate means like between different states. The same thing. That's what internet. I small. And when
I capital.
now don't ask me where if this internet starts in the beginning of the sentence, how will we distinguish? I don't know.
At the internet.
Yeah, the internet makes sense.
User, maybe user.
Okay, good.
If any
Users, maybe the customers, as well as users
admins.
Employee.
But that would be covered under DB, right?
Actually, DB, we thought that it is covering everything.
Yeah.
DB is database, right?
Yeah,
Yeah, so
database
the
has
database,
your
your
user
data, customer data, and the processes, standards, all those things.
Yes, but that is database, but user itself might be vulnerable, right?
Not that.
Employees, yes, bank, especially for the customer side, yes, customers can be an asset.
If customers want information like
Okay, I am
ID and
actually,
passwords.
better, these things will be the attackers. These things not be considered as assets, right? These are attackers, I'm sorry.
Can be.
Employees
Passwords
are
and the
the biggest
username
asset
should
of the
come
company.
as
Right.
But not for the bank website part, that is maybe for the organization.
all the other things in the database, including the
Okay, say the web admin servers, that's it, right?
First to log in itself.
Web admin server.
Right.
I mean,
Yes,
web
that-
admin.
That falls on the server, different servers, right?
Yeah, web server admins.
Yeah, servers, yes, servers. Servers and computers. That is the again part of the infrastructure anyway.
Web server में आ गया ना?
Yeah, web server.
No, web server is a software. Apache is a web server.
Yeah, yeah, hardware.
Yeah, but this part of infrastructure actually.
Compute.
And this API gateway, you can call it a web service. Anything else? Anything else? Ultimately money.
Money, payment
How?
gateway also.
In web server,
Okay. But actually transactions.
yeah.
These are transactions. It's the transactions.
Payment gateway.
Anything else? Okay, let's limit here only. Who might be the attackers? Any internet user?
Inside.
Yeah, they fall here, right? Because it is the port is open to the internet, so anybody can. Anybody needs money.
Bank employees. Insider. Insider and.
Yes, bank employees are one. Anybody else?
Probably in future AI.
Okay. Or the RPA, right? Robotic process automation.
Services themselves can also be, be unintentionally attached to other services. But that will also require hacker.
Okay, so you are calling about softwares, right? Different software installed in bank computers. Is that what you just said?
But wouldn't that be internet user passive?
No, that is user, but the software installed
So
maybe.
someone has to inject it, right? So the attacker.
Yeah, the
No.
other side, no?
No, I am using a vulnerable software. I know it is vulnerable, but I
That
just
wouldn't
installed
be
in my machine.
Attacker, right? That could be a victim.
Say, in my machine, I am a Dell employee. In my Dell, this is my personal laptop. In my company laptop, I installed something which is harmful.
Not deliberately, but that software probably attacked.
Deliberately or not
Not
knowingly,
But
whatever.
it attacked.
Yeah.
It can change some configuration settings.
That can change. That can, yes.
You can open some port or
Anything else?
Customer users themselves, sometimes they forget to, or they put simple passwords or something.
Users. Yes. Anything else? चलो ये वो let us see it from here to here on
if the internet user we covered.
Yeah, everything will be
Everything.
covered.
Okay. Now, who can attack? Internet user can attack web server? Yes, they can.
API gateway.
API gateway, yes.
SSL
SSL certificate, can they attack?
Yeah.
How?
Stored on web server.
They cannot attack the web server, but they need to, duplicate this SSL certificate and give the users who are trying to connect the bank website.
Basically, man in middle.
Difficult process.
Man in middle attack.
They
So
can
directly,
But in that case, SSL certificate is not the asset. In that case, asset is web server. Is not it? SSL certificate means I have a SSL certificate. My organization has a SSL certificate signed by a proper root authority. If somebody can steal that certificate, somebody knows my private keys. That is the SSL certificate as an asset.
Yeah,
If nobody knows my private key, then it is already.
private key would be the asset then.
Yes, actually SSL certificate means the private key.
Yeah. And it will be on web server. If they can hack on, yeah. If they can hack the web server, they can get the key. Not necessarily. I mean, the
Nobody usually, yes, they can if some foolish guy put it in the same machine. But usually they don't. They usually put it in the HSM. HSMs are the only solution to. In fact, that is if it is a PCI DSS, that is a standard. You have to use HSM.
It's a hardware based system.
Hardware based or software based or cloud based, whatever. In fact, in cloud based HSM is nothing like it is not a shared one. They actually put a hardware one. Exactly. Exactly. So even like in AWS, you can ask for a HSM, but that is not a shared one. They actually dedicatedly put it in there. It's a machine is there. But yeah, software HSM are also there. But though we call it HSM hardware, yeah, but actually it is a what they call it. It's a soft HSM something they call it. Okay, but yeah, private. I don't think internet user can directly access to the private key unless somebody like if their people are not.
If they get access to the internal computer network, they can.
Yeah, but
lateral
yes,
movement they can do.
Yes, but it is surely this one is
More
sure. Bank employees.
They already have access.
No, no.
I mean, they are inside network already.
HSM when if it is like the private key is one of the asset
they
only
are
the.
already inside network. Already they cross.
Yes, but SSL's like the private key
yeah,
is not usually not unless like he's like only one person who is designated. I think crypto officer has to be designated, so that crypto officer would know that one. Okay.
Unless both the first two guys are the same guy, then it will be different.
Yeah. Now, yeah, bank employee when he is acting as a internet user.
Yeah.
Because he has a lot of insider information. But private key, I beg to differ that unless the person like the organization is very much casual about the private key. Yeah.
They will not have access, but they can attack.
How
You want to get to the.
Yes, but for HSM, it is like there is always two-factor authentication even for them only, and usually what happens, the crypto officer and the organization lead, either the technical lead or the CEO, whoever, these two has to put the password together. It's kind of your locker when you use the access the locker in the bank. The bank employee and the customer both has to put their keys.
And considering hashing and salting with that particular method, it makes it much more.
Hashing and something is very easier thing, but like for keeping the private key, in fact there is a standard around it. If it is a PCI DSS, there is a standard and it says that how you have to keep your yeah. It has to be fixed. So it's you have to keep it in HSM. Who know the password for who that access to the HSM. Where you have to put the HSM, it is not in the same network in the bank. It has to be a completely separate network. So all these things are there. Okay, and what else? Then let's see. What internet user can access is web application. Yes, very much. It is the then infrastructure. No, they cannot access.
Not really.
But the bank employees can access. And software installed in this can access DB. Bank employees can access DB. Okay.
Even internet users.
Even logs also they can access. Bank employees.
Logs, yes. Logs can be accessed. Internal network can be accessed.
Servers and computers, if they are the admins or something.
Yes. Some of the employees can do that. Now that will happen in the next iteration. First iteration, this we consider. Second iteration, there will be attacker will be the bank employees, assets will be these, and then we will do the we will need to do the second iteration. Or for one single attack, again we have to find one single asset, we will find what are the possibilities. That time we have to find that who are the attackers. That time we have to more fine tune these things, or we have to go more granular. But if initially you start thinking in that granular level, then it's a problem. You cannot finish the threat model. So first, that's why we start with first one, we call it the context level threat model. Then it comes level 1, actually a context level, or level 0. Then level 2, level 3, as many as we want to go. Depending on the depending on the asset, or depending on the sensitivity of the system. And what else?
Transactions by users, their own transactions.
Their own transaction, but
I
can they
think you
manipulate
as a
that?
customer can be part of internet user hacker also. Because
Yes, actually they are subset of this.
yeah, subset of. Because
But,
anyone
no,
intentionally
they-
hacking in can be considered as hacker.
But users themselves have their own.
Yeah, but there are
But one
difference is
is
this.
an attacker.
Some of them has
Their own.
no
But
access, and some of this has partial access. I can access my own internet banking, at least my own account I can access.
Yeah.
So partial access is there. Now, what will happen is that bank portal, like I just open in my own account, and then just change some of the session key, and I can just go to another one's account. It can be possible, right? At the end of the day, this is nothing but a session key, and if somebody knows, okay, this session key is a function of my customer ID, I can generate the new session key, and I can just change the session key. Okay? Anything else? Yes, I understand. Yes, even I am hungry. Anything else? Just quickly finish this one. Then we'll draw this into stride Microsoft Threat Modeling model. The same thing we have done here. We'll do the same. We'll practice the same thing in the Microsoft Threat Modeling tool. Anything else? Or do you want to keep it till this much thread we are accepting for our time? Okay. So maybe there are more, but at least we understood that how things happen, right? We understood. We can go more deeper and deeper. That's fine. We are not going to really doing the threat model
I
and
think the
secure bank.
combination is so massive that we can't cover it.
Yes, actually, and it requires experience also. Even with my experience also, I am not very confident when I am doing a very threat model from the scratch. Even I usually pull in my colleagues.
Always expect the unexpected. You don't know what will happen.
So yeah, that happens. So it comes with, so initially when I started threat modeling, actually I wanted to consider everything in the context level only.
It's not called-
Then after
the
with the experience it comes, which one I will consider, which one I will not in the context, and then which one I will go in the next level. That comes with the experience. Okay. Okay, let's take the lunch break.
Control is there, right? Is very bad. फुल घर में ही है घर में ही
Also, it's a 1 hour.
ज्यादा भी हो सकता है डिपेंड्स ऑन फूड और कम भी हो सकता है तो और इनको गिफ्ट दे दो ना लास्ट सेशन में दे दो तो गायब हो गए नेक्स्ट के
Srini, you are taking the lunch break for 1 hour.
Okay. Okay. Thank you.
नाइस प्रेजेंटेशन मार्ट तो गरीबों में दे लेना दे ले लेना मुझे समझ में नहीं आया होगा मुझे तो नहीं बताएंगे वो कमेंट करेंगे वो पता है वो इंटरव्यू के बाद हम लोग 15 मिनट बातें करते रहे मैं बोला इतना रात को आप लोग काम करते थे वेरी अप्रिशिएटेबल और वी हैव सम इंटरनल पॉलिसी वी डू इंटरव्यूज बिफोर 9 एंड आफ्टर 8 बोला यस मतलब ये कौन सा इंटरनल पॉलिसी है?
ऐसा नहीं लगता है हमारा।
सी ग्रुप सी थी रात को वो भी सैटरडे 7:30 से 8:30 बजे कॉल करना पागल लगती है
और बार बार एक ही